Good afternoon, everyone, and I would like to thank you for taking the time to join us today for our live webcast in joint collaboration and partnership with HP. The focus of our webinar today is on HP ALM integration with Microsoft Team Foundation Server. We will be looking at both HP ALM and TFS strengths and also their differences in the way they function. Towards the end, we will also do a demo on how both integrate. I am proud today to be joined by my colleague, Valéry, who is the CTO of Test House. I'll quickly go through the agenda with you, or my colleague Valéry will. The presentation will be 40 minutes plus Q&A at the end. Before I pass you over to my colleague Valéry, please feel free to type in your questions on your Q&A pod now or at the end of the presentation. We will answer all or most of your questions if time allows. A full screen is also available at the top of your screen if you need this, which might be useful when Valéry does his demo towards the end. So without further delay, I now pass you over to my colleague, Valéry.
Thank you very much, Melanie. And good morning, everyone. So we're here for about 40 minutes on this interesting subject, which is looking at the HP ALM Synchronizer, so the latest release, which is 1.6. And we'll look more specifically at the integration between HP ALM, or Quality Center, and the Microsoft solution, which is TFS 2013, the latest release. So just quickly a bit of background about myself, just for you to know who I am. So I'm coming about 10 years ago. I fell into the testing market, I would say, where I started to join a company as a support engineer. A company was called Mercury Interactive. Didn't know much about what was testing at that time, but I quickly understood that Quick Test Professional, Test Director, which became Quality Center, were two very interesting products. So Mercury Interactive is obviously the company that started all this and then was bought a couple of years later by HP. So after that, I left Mercury Interactive and I started my own independent company as a consultant, working with HP Software, Quality Center, Quick Test Professional, Load Runner, and even Business Availability Center. So different products from HP, and also got an interest in other tools, specifically Microsoft ALM with Visual Studio and TFS, and some other open source products. During both nearly 10 years, I worked with a lot of companies, FTSE companies and small companies of all sizes, and I had the opportunity to work with many different technologies. And recently, just beginning of this year, I joined Test House Limited as a CTO, and I still work with both different products because I'm a specialist with HP, Microsoft, IBM, and many others. So that was a brief introduction about myself. So the agenda for this webinar is very simple. So we'll first look at HP ALM. So it's just an introduction. So we won't go in deep detail. It's just for you to get an understanding of what is ALM. Then we'll look at Microsoft TFS, latest release, which is 2013. Same process here. And then we'll move into the ALM Synchronizer with a small overview of what it can do. And then we'll look more specifically at the integration between ALM and TFS. Once we finish all this, we'll move into the demo, where hopefully you will see how the Synchronizer works and what added value you can get out of it. And at the end of this, we'll move on to the Q&A session. So let's start with the HP ALM introduction. So before I begin any further, what you have to bear in mind is ALM, it's actually interesting because it's either called ALM or Quality Center, but it's kind of the same base product, is a QA lifecycle tool, and there's different editions of it, so for different needs. So the HP ALM is the one with all the features, and then you have smaller editions, so QC Enterprise is a slightly smaller edition. You have the ALM Essentials, which is for very small companies, so for small companies or small teams who want to get started with ALM. And then you have a more specific version, which is called ALM Performance Center, which is dedicated to performance testing. So just to summarize here, I've shown a couple of features. There's more than that, but you can see depending on the edition, those features might be there or might not be there. So if you take lab management, it's only available in ALM and Performance Center, and so on. So it's not because I put crosses all over the essentials that he has nothing. He has the basic features, but here was just to show some of the differences. So like I mentioned earlier, it's a QA lifecycle management tool. So there's different modules, and here I just summarizes four of them, which are probably more, yes, just an introduction about it. One is test requirements, so we'll look at it. So that's one aspect that can be synchronized with the Synchronizer. So test requirements, this is where you store your requirements asset, being functional requirements, non-functional requirements, security related, and so on. And you can even create a structure like groups, folders, and so on. On the other side of the life cycle, you have defects management. So you can obviously, if you have a QA solution, you want to manage your defects in the same tool. So within Quality Center, you can raise defects, and they can be raised either using ALM or using a tool which is called Sprinter, which is for manual testing, manual test execution. And what is interesting with ALM is you have the end-to-end traceability. So once you create requirements, you can move on to creating test cases. Those test cases can be manual or automated. You link those requirements to the test case. You then execute those test cases, and if you find issues, you can raise defects. So those defects will be linked to those test cases. So you have an end-to-end traceability. So you can know which defect relates to which requirement. And then you have some other features. So one I wanted to mention here is the BPT framework. So BPT stands for Business Process Testing. It's the HP solution for quickly developing manual and automated tests. And it has some features which are called accelerators for specific products like SAP or Oracle, which enables you to develop even more quickly. Sorry. So just a quick view of some aspect of HP ALM. So I mentioned a module which was called requirements module. So we'll go back to this one in the demo, but you can see it's a tree structure, and each item represents a requirement. And for each requirement, you can see that there's a set of fields. We can attach documents and so on. So this is what you get with what I would call the Fit client, which provides a rich experience. But nowadays, you also have a new functionality. I think it's new in version 12, if I'm not getting wrong. Is you have a web-only version for the requirements, and you can access your requirements in the same way, and you can manipulate them using nearly any type of browser. So here I just use Google Chrome to show that. On the other side, so this is the second aspect that can be synchronized. On the other side, you have defects. So again, defects you can see here through the rich interface. Defects are stored as a flat list, but don't forget there is traceability in place, so you can link those defects back to the requirements we've seen earlier. And again, the defects module also has a web-only interface, which allows you to see, manipulate defects directly using a browser. And if you're a manual tester, while you're running your test, you probably want to raise your defect using Sprinter. So instead of using those two UI we've seen earlier, as a manual tester, you would be running your test cases manually through Sprinter, and then if you find an issue, you can raise a defect directly through this interface. So we have different means for interacting with the ALM database. Okay, so that was a quick intro of HP ALM and Quality Center. So now let's talk a bit about TFS. Even before I move to the next slide, this one is quite interesting. So it's an application lifecycle management tool. So it goes a bit further than what HP does. HP is very focused on the quality assurance aspect, whereas Microsoft has development tools such as Visual Studio. So they have a broader scope where you can specify your requirements. You can develop using Visual Studio or any other tool. So you develop, you test, you then deploy, or actually build before that. You can deploy, monitor in your live environment, get feedback from stakeholders, and then move to the next iteration. So being agile or using a waterfall approach. So TFS, what is TFS? So TFS you see on this slide is actually the central aspect of this picture. Sorry. So it's actually a database with a set of APIs, but it's actually like a placeholder for data. It stores what we call work items, and around this we have many tools which can use this database. So obviously the most obvious one is Visual Studio, where you would use the TFS to store your source code. You will manage your project. So if you have a backlog item, if I use an agile methodology, you have your backlog item, you have your task, then you implement those tasks. And then the testers would be using Test Professional to test these products, these projects, and then they would manipulate test cases, defects, which would be fed back to the developers. So you can see that we have an ecosystem here, but outside of this, there's other capabilities. So you can integrate with Microsoft Office. That means you can manipulate all your work items outside of the development tools. You can use SharePoint to do your reporting. You can use Team Explorer to have like a standalone integration with a Team Foundation server, and you can even integrate with other tools such as Java-based tool. And you have web access, where you can use a web interface to interact with it. So we can see that there is many ways of interacting with TFS. So just to summarize a few of them, we'll see in the demo as well. So obviously Visual Studio is the main one. So you manipulate the items within your TFS database through queries. So you see here on the right hand side you have queries. You run a query, and then you get the result. So you get access to some of the work items, and you can open them and edit them to update your work items. Another interface you can use is Microsoft Test Manager. So again, this is for the manual testers when they want to create their test cases, when they want to execute their test cases, and also raise defects. So this is an example where we look at a defect here. And the third interface I want to mention here is web access. So through a browser, you can access, again, those work items. Here we see defects on the screen, and we can manipulate them the same way. So the idea is to have different means of accessing the data, but being able to update this data using your favorite tool. So if you're a developer, you use Visual Studio. If you're a tester, you use MTM. If you're a manager, you might want to use Microsoft Office. Again, that was a quick overview. We only looked at some aspects which are interesting for us with the ALM Synchronizer. So the next section is moving on to ALM Synchronizer. So a bit of understanding how this hooks up together. So if you look at what we need to solve here, we have HP ALM, a server installed somewhere, and then we have another tool. So this is the endpoint 1, and we have another endpoint 2, which can be anything. It can be a TFS, ClearQuest, and so on. So there's different tools you can integrate with. What we want is we want to exchange data between this endpoint 1 and this endpoint 2. So what we have in the middle is we have the HP ALM Synchronizer, and using a client interface, we configure this server to be able to extract data from one and send data to the other and do the same thing the other way around. So we have a Synchronizer client, which is used to obviously display our configuration and also configure the HP ALM Synchronizer server. And we have the server, which is always on installed on the server, which automatically synchronizes data between the ALM server and the other endpoint. Okay, this ALM Synchronizer server is very easy to install. In terms of requirements, it's very flexible. You can install it on nearly any Windows operating system, any modern one. And in terms of database, you don't even need to install a database. It will install a PostgreSQL database, which will be used locally. In terms of support, it supports 4 different products. So here we're looking only at HP ALM 12, so there's different versions for different version of ALM, but we're looking only at 12 today. So the endpoint 1 is always HP ALM, and the endpoint 2 can be HP ALM, so there's an so you can exchange data between 2 ALM servers. And unless I'm wrong, you can only do this if you have an ALM edition. So if you have any other edition, you're not able to do that. You can synchronize defects and requirements. If you use some other tools, so there's integration with IBM Rational ClearQuest and IBM Rational Requisite Pro, which provides either defect or requirement synchronization. And it seems that ClearQuest 8.01 has integration with defects and requirements. And if we look at more specifically at Microsoft TFS, since version 2010, you can synchronize defects and requirements. So how does this work? So you have your 2 servers, the LM1 and your TFS1, and what you need to set up in between is what we call a synchronization link. So obviously, to have a synchronization link, you need to connect to those 2 servers. So for ALM, you need the URL to the server. You need to have a username, password, which you will use to connect to this server. And you need to specify which project you want to access. So this synchronization link is created on a project basis. So if you have 10 projects in ALM and you want to synchronize those, you will have to create 10 synchronization links. On the other side, for TFS, you also need the URL. You also need a username and a password to access this TFS server. So bear in mind, those users need to have enough permissions to pull data and to update records. And you also need a team project, which will be part of the team project collection. So again, it's a project-to-project synchronization. So once you specify this, you also need to specify which type of data, which entity type you want to synchronize. So you can either synchronize requirements or defects. And if you want to do both, you will have to create 2 synchronization links. So once you created this synchronization link, you can then specify a few things. So I will go over quickly some of them. But you can specify a filter. So you might say, oh, I'm only interested with a subset. Maybe in your project you store defects for many different applications, and you just want to synchronize some of the defects of a specific application. So you can use filters. In ALM, it's called favorites. So it's your filters that you save as favorites. And in TFS, it's called save query. So it uses the usual interface you would use as a manual user of the application. Then you can specify rules. So where you can specify when something occurs, do you want to update or do you want to do nothing, or do you want to delete or do nothing, or do you want to create or do nothing. So you can limit the scope of the synchronization. And the most important part of this synchronization link is a field mapping. So when you create or when you update something, let's say on ALM, when you update the title or the description field, or when you add an attachment, where does it go on the other hand? So where does it go in TFS? So you need to specify this mapping, and so you need to map two fields together. You need to provide a direction. So for instance here, the created by in TFS, if it's being changed, it will be updated in HP ALM, but not the other way around. Or you can have a bidirectional synchronization. So that's something that you can do. But even if we drill a bit further, you can do a mapping at the value level. So if you take the status field, in HP ALM, you will have new, open, fixed, closed, so different states, which might not be the same in TFS. So you have to tell to the tool, when you create new in ALM, it will be new in TFS. But when you close on ALM, it will be closed, it will call done in TFS. So you need to specify this in order to set the correct value on the other end. Okay, and so that's the setup. So once you set up, you need to synchronize. So there's two types of synchronizations. So you have what we call the full synchronization. So it just looks at all the records. So let's assume here we're looking at defects. So it just gets a list of all the defects, and then it goes through each item and verifies that all those items have not changed. And if they have changed, it will perform a synchronization between both endpoints. So obviously this full synchronization will look at what happened in ALM, go through the list, and do the same in the TFS server. So it's a synchronization both ways. Obviously that's a synchronization that takes the most time, because it has to go through all the items. The one which is performed more often is called the incremental synchronization, and what it does is it looks at the last time it did the synchronization and say, okay, HP ALM, what has changed since the last synchronization, and it just gets a subset, and then looks if any changes have occurred, and obviously changes have occurred, so it will look in each of those items and synchronize them. So obviously incremental is a lot faster than the full synchronization. And all of this, so you can force a synchronization, you can do one-off, but obviously you want this to be executed and attended, so you would use the scheduler, and you can perform synchronization at regular intervals, being full or incremental. Bear in mind that you cannot be smaller than 5 minutes. Just a bit of let's call this technical information. Once you created a synchronization link, there's some validation aspect, because we want to make sure you're not actually doing things wrong. So the validation will look at the mapping fields you created and make sure that whatever you map from the endpoint 1 and the endpoint 2 is compatible. So if you have a string in endpoint 1 and you want to write this string in a number on endpoint 2, it will raise this as an error and tell you cannot do this. So here you have an example where we have a double field and a number field which are incompatible, so it's raised as an error, and this synchronization link will not be enabled. So we talked about what could be synchronized, so defects and requirements. So for requirements, it's a slightly more complicated because obviously requirements is also more complex. We've seen that defects in ALM is just a flat list, but requirements is structured, and there's different requirements type. So when you integrate requirements between ALM and TFS, you need to specify a few more things. So you need to specify what will be mapped to a folder. So you need to tell, okay, in TFS, this work item will be mapped to a folder in HP ALM. And for each requirement, So again, a requirement will have to be mapped to a work item in TFS, but for each requirement, you will have to map each requirement type. So we have different types, and you have to map it to a field in TFS. So we'll see there might be some need for some customization on the TFS side. It's not too difficult, but you might have to do that if you want to synchronize requirements. So in this example, you see this is a folder. So this is just a way to structure your requirements. It doesn't carry any requirements information, and then you have different requirements type depending if it's a security, non-functional, and so on. And once and this is an example of a mapping. And once you have done this, then you have to go for each requirement type. You have to do the field mapping like you did it for the defects. Okay, so here we see an example of field mapping. It looks very similar to a defect. If you feel the tool is quite limiting, so you might want to have a more complex exchange of data between both endpoints, so maybe you have to do some transformation or the logic is a bit more complex, then you will have to do it in the other tools. So you will probably use workflow customization. You might add some more fields which will be hidden, but they're used to actually manipulate the data. So in ALM, you would use workflow customization, and in TFS, you would customize the MSF template you're using, and you would modify your work item. So this is possible, but obviously this involves a lot more work. So I think we've seen enough about how does it work. So we're going to move on to the demo. So in this demo, I'm going to show the integration between ALM and TFS, from ALM to TFS, from TFS to ALM, and I will also show that using different tools, it doesn't matter, the data will get synchronized. So before I move to the demo, a quick explanation of the environment I'm using for this demo. So what I have set up is 3 separate servers. So one server which is hosting HP ALM 12 with a SQL Server database, and another server which has TFS 2013 with another SQL database. So they are completely separate. They in a normal world, they're not talking to each other. But what I did is I set up another server which has the Synchronizer server, and which has been configured to interact between both ALM and TFS server. And on this machine, I also installed several clients, or clients for TFS and clients for ALM, to demonstrate that when we change data, it gets updated on the other endpoint. So let's move on to the demo. So briefly, let's have a look at the ALM Synchronizer. So this is a client interface, which allows me to interact with the server data. I have set up 2 endpoints, so one for defects, one for requirements. Sorry, not 2 endpoints, so 2 links. So you can see here I specified how we connect to HP ALM, how we connect to the TFS server. You can see where I use 2 different usernames, and I synchronize a project called Synchronize on ALM and a project called Synchronize Scrum project on TFS. In terms of scheduling, I have a schedule, but for the demo, we want to do it more often than 5 minutes, so I will actually run it manually. You can see we can specify filters to only synchronize certain defects. I haven't set anything. We can specify rules to define when do we want to update from one side to the other. And then the interesting part is the field mapping. So we'll see a couple of examples. So in HP ALM, the defect title is called summary, and on TFS it's called title. So you see this information on the left and right hand side is what we call the schema. It has been pulled automatically by the server, and basically what I do is I select a field in ALM, I select a field in TFS. So sorry, I need to be in editing mode. I select a field, and I'll just say map selected, and it automatically creates a link between those two fields. This only works if those two fields are compatible, so obviously this is not a good example. I'm just going to remove it. But here you see valid mappings. And if I just quickly scroll to one, summary and title, you can see they are both string and they are both read-write. So that means a value in this summary field can be written, in this field can be written. They are of compatible type, they are both strings. So we can map them together. It can be a bidirectional mapping. And what you can see as well is this flag next to it. This means this is a mandatory field in HP ALM, and this is a mandatory field in TFS. So that means you cannot create a synchronization point without mapping those mandatory fields. So you can see severity is another mandatory, and it's been mapped somewhere. Here we go, severity. Okay, and we did the same for requirements. So briefly to show how it works. So for each requirement type, so they were listed here on both sides, what we did is we actually mapped, or in TFS we had just a subset of what is available in ALM, and we mapped a group requirement type in ALM was mapped to a group requirement type in TFS. And then for each of those mappings, for each of those mapped requirement type, then we defined a field mapping. Okay, so here we took a very simple approach where we only mapped the title of the requirement. So you can add a lot more if you want. Okay, so we have two synchronization points. So let's move on to synchronization some data. So let's start with ALM. So I'm just going to log on to Quality Center. And I'm just going to start with a defect. Let's just create a new defect. This defect. Okay. Just added a title and a description. Just create this defect. So the summary field was the only mandatory field in this defect module. So now what I want is actually make sure it's not there. So I'm just looking at all the defects. Actually, there's a lot of them. If I go back to Quality Center, just going to filter it. Okay, there's nothing there. So now I go back to my Synchronizer. I'm just going to force the synchronization. I just enable it. So we're doing an incremental synchronization just to update what has changed since the last time we synchronized. So you can see at the bottom the log file. And you see processing entity 1 of 1. So it means it found a change since the last synchronization. So if I move back here and run my query again, hopefully we can see a new defect which has been created. And we can see the title and the description which has been updated. So now, bug 45 in ALM is synchronized to defect number 85 in Quality Center. So if I just say this is my new description and synchronize again, It will hopefully detect the change. There we go, processing entity 1 of 1. And if I will go back to here and refresh my view, you can see that the description has been updated. So we can see that there is a two-way synchronization. And this will work no matter what client interface you're using. So I'm just going to do it, let's say, from a TFS web access. Going to my Synchronized Scrum project. Should find my defect around here. Let's modify another defect here. Let's create a new defect, actually. Okay, I'm just creating a new defect in TFS using web access. And hopefully, again, it will detect a change. And we should have a defect number 86. Here we go. With a new defect creating from web access. Okay. And the same principle applies to requirements. I think we're running a bit out of time, so I will stop the demo here. But whatever client interface you're using, you are able to, sorry, I'm going to do two things at the same time. You are able to synchronize the data between both endpoints. Let's move on to the Q&A session.
Thank you very much, Valéry, for a wonderful introduction and sneak peek of the HP ALM integration with TFS. As Valéry mentioned, we are now taking questions, so if you can please type your questions in on your Q&A pod. We'll hopefully answer all or most of them. If time does take a while, then we will take some of them offline. I have the contact details on the slides in the next couple of minutes, but we'll take some questions now. If you have, please, to Valéry and whatever questions you have on the presentation today and obviously of the demo. Okay, we have a few questions coming in. So first question, can we map only a subset of the requirements?
Yes, Melanie. Yes, you can do that, actually, because what happens is you might have requirements, a big requirements structure where you have multiple products, but those products are mapped to different projects in the other endpoint. So you can actually select a specific node in the requirement and specify this will be the root node for the synchronization purpose.
Thank you, Valéry. Another question for you. Why do we need to run full synchronization? Okay,
so you have two types of synchronization, and obviously the full one takes most of the time, and but you still need to run this full synchronization. Just to give an example, if you delete a defect, when you go to do a partial synchronization, it will look at what defects have changed, and obviously if it has been deleted, it won't be in the list. So your synchronization will not pick up the fact it's been deleted. But when you do a full synchronization, it will detect that this defect is no longer there, it's no longer in the full list, so it has been deleted, and it will make sure it's being deleted on the other endpoint. If that's what you want. Obviously there's rules, so you can say if I delete it, I still want to keep it on the other endpoint. So that's one example. Another example is if you have a tool that integrates, let's say, with Quality Center, and you actually update defects, those dates are set in the past. when you come to do the partial synchronization, it will not detect those defects were added because the dates don't match, and only a full synchronization will detect that those defects were added.
Next question. How can we synchronize test cases? Is that even possible?
Unfortunately, with the ALM Synchronizer, it's not possible. You can only synchronize requirements and defects. If you want to synchronize other type of entities in ALM, you either need to use some other third-party solutions, or you need to write your own solution using maybe some VB scripting.
Next question, I think it's a follow-on question. Can the synchronization server run on virtual machine?
Good question, and the answer was in front of you. Actually, all this demo was run in the cloud on virtual machines, so the answer is yes.
Next question. What happens to attachments? Are they synchronizable? What about the rich text?
So for attachments, I haven't mentioned it through the demo, but maybe you've seen it. There's an attachment type. So you have the attachment type, so you can map two fields which are of type attachment. You can map only once, so you cannot have two fields with the attachment type. It wouldn't work. But yes, so if you map those attachment fields, it will automatically synchronize the files. Bear in mind there's some limitations. So, for instance, if you rename the file, it will consider that you deleted and created another file. And if you delete a file and re-upload a file with the same name, it might not detect the change, and it will not synchronize the file on the other endpoint. So that was one question. What about rich text? So for rich text, it's a lot more limited. So it will be seen as plain text. So if you have a rich text field and you put something in bold, underline, different colors, or insert an image, the most likely scenario is at the other endpoint you will only have a plain text. So if you do a one synchronization one way, then you edit your plain text, it will overwrite the text on the other endpoint. So you have to be careful with that.
Okay, I think we'll take the last question here, Valéry. Can we avoid filling in mandatory fields?
Very interesting question. The answer is no. If it's mandatory, it is from the ALM point of view. So if you say I'm creating a defect and you don't provide this value, ALM will reject it. So it's not Synchronizer fault, it's how ALM is designed. So the same applies to TFS. And if you have issues like this, there's different options, but one would be to make it non-mandatory. And if you still want it to be mandatory in, let's say, QTLM, you will make it mandatory through the workflow customization. So it's seen mandatory in ALM, but it's not seen as mandatory with the Synchronizer.
Thank you, guys. That concludes our Q&A session today. Again, before we go, the recording will be available in the next couple of days. If you do have any further questions to Valéry, please feel free to email them to me. My contact details and my email address is there, and you can even give us a call on our office number. So thank you all very much once again for joining us this afternoon, and hope to see you all once again on our next webinar. Goodbye.